everyone. Welcome back. I am Gauri Ramkumar. I work with Bespoke 360 for the past 3 years. I've been working as a client relationship manager, looking after the client onboarding process. I'm very honored to welcome Dan Rosanova. Dan has worked in the messaging space almost his entire career, industry experience ranging from financial services, insurance, retail, logistics, etc. Dan's currently working as a principal program manager, Azure, with core responsibilities for messaging services, event hubs, service bus, and relays. With all your hands put together, I would like to welcome Dan to the stage now. Thank you.
My name's Dan Rosanova. I'm a principal program manager lead at Microsoft, responsible for all of our messaging services. And I'm here today to talk a little bit about messaging and where we are today and where we're going and where we came from. Really quick background, messaging services in Azure, there are really three that we usually talk about. The first being Service Bus. Anyone here using Service Bus? Good, a few people, excellent. Yeah, that's a good one. For this type of crowd, I think it would probably be the most familiar service. The next one being Event Hub, which is telemetry service. It's really a data streaming service. Anyone using Event Hub? Okay, a few less people, okay, good. And then finally Relay, which is actually our older service, but we made some big investments in lately. Relay is really kind of unlike the others, so I can always tell who's a security person in an audience because the terror on their face when I talk about Relay. So we'll see. Anyone using Relay? Wow, more people than I thought. Okay, excellent, cool. So just to start off, some quick background numbers. I like to show this slide every time I'm here because it shows our growth. The last 31 days, I think it was, we had 23 trillion, it's actually 23.4 trillion requests for event hubs. That comes down to 8.5 million per second. Over the month, we had almost 5 nines on that. So these are just some quick stats. They're individually not that important, but collectively they're pretty interesting to show that we are doing a lot in the messaging space in Azure. I like to throw out that 23 trillion number because I don't see any other cloud provider actually say what their numbers are in this space. My specific competitors at Amazon and Google are silent on the subject, which kind of makes me laugh. And even our other messaging services are actually growing a lot. Relay, before we did hybrid connections last year, grew a lot just on its own. But since the last time I was here for Integrate last year, this is what the change has been for Event Hub's traffic. We went from 2.75 trillion to 23 trillion. So that's a pretty big jump. We are 1 month later for this conference than we were last year. So it's in 13 months, it's not in 12. But in the time I'm on this stage, that means there will be 23 billion requests to that service. It is a global service. All of our messaging services are in every Azure region. Internally we call that ring zero. It's like compute and storage, so we have to be everywhere. Which is why we get these kinds of request rates out of it. What's interesting too is that business tends to follow the sun, so even though it's quite late in the US, which is why I'm tired, it's not here, so there's a lot of activity going on even now. The rate's actually increasing. I checked this right this morning, right before coming on stage, and the last 7 days had 5.56 trillion requests. And we did hit 5 nines for that, so still trying to get the 6 nines, which we get sometimes, some weeks. But that still means there were 28 million failures. So nines won't really help you here. This is that kind of problem. The first time we hit like 10 trillion or something, I went over that with my corporate vice president. And he was very happy and proud of us until I mentioned the failure rate, the number. How many people here do 28 million requests per week of anything? Like, yeah. So this is actually a good example of why you want something like Service Bus 360. Because if those 28 million are some of yours, you probably want to know about them. Those failures aren't things like losing messages. They're just us getting exceptions, people being, actually that doesn't count throttling. It would just be transient types of exceptions. Actually, Service Bus 360 is a really good platform for this. I've been working with Sarvan and his team to make sure that we give customers what they need for that. My business is the platform itself. It's not the applications you build on the platform. So it's hard for me to focus on those things and my team. But it's you look at the job that they've done with BizTalk 360, which is phenomenal, and bringing those sorts of capabilities to Service Bus is something I'm really happy for. So a quick history of messaging, just real brief. I won't go too into this. If we look at our timeline here, we can see that, which way does this start? Okay. That's really going back through the 80s and up until today, and different messaging products coming along over time, like MSMQ or Tibco or BizTalk, Rabbit, Service Bus, Event Hubs being our latest one, and the industries that use it. So you've got a lot of industries. I've actually worked in all 6 of these. So is anyone in the audience working in any of these 6 industries? Yeah? Okay. So the landscape today. The landscape in messaging is actually pretty interesting. It's actually going through, I kind of joke with people that messaging does well in odd decades. So it's a good decade for messaging right now. There's a lot going on. A lot's happening in the cloud. So all of the cloud vendors are really starting to play around with messaging much more seriously. There's still quite a bit happening on-premise. And there's a lot happening within software, being on-premise or running it in the cloud and in services. And the thing that I'm really proud of us to be able to say is that Microsoft's covering all of these. So whether you're on-premise, whether you're in the cloud, whether you're running software, wherever that happens to be, or using cloud services, we're doing all of them. So we really are the leader in this space of messaging like this. So other vendors can claim one little quadrant maybe, and we get to pull ahead by saying we're providing everything. But messaging's changing a lot, and it's changing the way you use messaging. So if we look back to how we used to build stuff with messaging and how we used to, actually BizTalk's kind of an example of this, how we used to build solutions, is that we spent a lot of time investing in a messaging platform. So we spent a lot of time selecting a platform, comparing it to other platforms, and it was a big commitment. You're buying Tibco, or you're investing in MQ, or you're buying BizTalk, and you're going to have to live with that, and your company's going to have to live with that for a long, long time. So it was really more like a marriage. It took me 17 years of dating my wife to marry her. So that's not, you can see how quick I am to buy new messaging platforms, right? So the cloud's not like that. It's a little bit different. That's a good pattern for people, probably not for technology. The cloud's more like Studio 54. You're just kind of showing up and seeing what's happening. And the landscape is evolving a lot. That's recorded, isn't it? Yes. I'm going to blame jet lag. So the messaging landscape is changing, and what we see, we already fill a lot of these, but you've got things like live socket messaging. So if you think back to where TCP/IP was in the early, maybe mid-'80s, maybe mid-late '80s, where we're really still at an early stage of networking, and we've built a lot since then. Messaging is kind of like that today. TCP networking is kind of like a utility at this point. It's given, but what you build on top of it's what's changing. So live socket relays, simple messaging, things like Amazon's SQS or Alibaba's CMS or storage queues, simple messaging stuff. Enterprise messaging, this is the type of messaging that everyone in this room probably knows and thinks of. This is the sort of Tibco type stuff, the MQ series, Service Bus. And then big data and streaming. So these are kind of the 4 big quadrants of things that are happening in the messaging landscape right now. The cool part for us is that Microsoft is in all 4 of these. We're not alone. There are other people in them too. But as you look at these and where these players are, we're really the only cloud player in all of these. So we're really kind of being innovative in that area. What's interesting is that messaging is becoming more specialized. This is kind of like what's happened in labor markets, actually, even in IT. We all become more and more specialized into specific roles. It's not like you just hire a mainframe developer anymore and they do everything that was required on a mainframe. So the branches of specialization are really focusing on specific features for the tasks you're trying to accomplish, for the functional areas. And the result is that a single application or solution is probably going to start using more than one messaging platform at a time. So a good example of this would be someone using Service Bus to do like e-commerce or orders, and using Event Hubs to do telemetry and logging on the same solution. Is anyone using 2 messaging products on the same Same solutions ever? Yeah, some people. Probably more than you think. My observation, and God, I was terrified hearing my introduction. It's been almost 20 years in the messaging space, is that enterprises like to have an odd number of messaging platforms greater than one. So you'll usually, that's what you're doing with BizTalk, is bridging like MQ and TIBCO. So you'll see a lot of that, and all of this is made possible because of cloud messaging. This is what's making this easier to do, and it's not unique to messaging. It's happening all over the cloud. This is a great graphic that I put together when I couldn't sleep last night of the services today that we advertise in Azure. So it's not really meant to be read, but they are all on there. When you're building an application today, or doing something in the cloud today, the whole idea isn't that you're going to learn all of this. That's like learning all of Win32 or every feature in the .NET framework. What you're going to do is you're going to pick the pieces that you want to put together for your solution. So you'll maybe do some logic apps, some blob storage, some service bus, and some other services that you'll just grab out of there, Stream Analytics or something. So the idea now is not so much that you're going to buy one big monolithic package, it's that you're going to pick and choose the best pieces for the specific tasks you're trying to accomplish, which is pretty interesting. It's a very different model than what we're used to in the package software space, especially at Microsoft with something like BizTalk where we give you everything in one package. There's no like a la carte pricing for it. So it's very powerful though. There's another shift happening in messaging too though. And what we see in this shift is the shift between on-premise and cloud and the shift between simple and enterprise messaging. I haven't come up with a better term than enterprise messaging. If anyone has suggestions, I'm taking them because it's hard to describe that concept, especially once you've spent 20 years in it. And so the shift that's happening here is a lot of the enterprise messaging is actually moving to the cloud. And this can be in either like a lift or shift sort of strategy, like, hey, you're just going to host MQ in IaaS in Azure. Or it could be that you're moving to Service Bus Premium, giving you the same types of features and reliability as MQ. And the other shift is to simple messaging, which is really sort of net new messaging. That's where people maybe could have been using like something like MSMQ on-prem, but in reality what's happening is that there's a whole generation of developers now just learning about messaging and reaching for simple queue solutions to help them out with a variety of things in almost any platform. So really quick, a comparison then between PaaS and software. This is an interesting one. When you look at the software space, you're looking at buying software, running it, whether you're running it on our IaaS or Amazon's IaaS or whatever. When you look and compare that to PaaS, these are pretty different. So when you think about PaaS, we, as a provider, as a vendor, as a cloud vendor, do a lot of things that you don't have to do. When you're doing non-PaaS, and this doesn't matter if it's IaaS or not, you're still having to do OS patching, runtime monitoring, load balancing, software patching, and fixing your software all the time. We do these things continually. Those traffic metrics that I brought up, consider that during that month, we did 2 deployments, and we still have to keep going at 8.5 million messages a second during our deployments. So, that's just how it is. So we do all of these things. You're getting this as part of the service. I like to draw this analogy. I like gardening, although I have a very, very small yard. The richest man in the world could only afford 5 acres in Seattle. So, property is at a premium there. Downloading and using softwares like this, like Kafka is a good example, or maybe RabbitMQ. You got an empty lot, you got some seeds, and you got some tools, you can have at it. There are other sort of platforms, like pre-configured platforms. EMR is one example, which are kind of PaaS, kind of IaaS++, and it's like moving into a house with a nice garden. Where's Justin? Someone on my team moved into a house with a really nice garden and doesn't really know how to garden. So his garden doesn't look like that anymore. So it's a cool garden though, or it was. Then you get to something like this. This is what a real PaaS service is like. Unless you're the Emperor of Japan, you don't have a garden that looks like this, and even he doesn't take care of it. So this is a service that you're purchasing, and it comes with this stuff. Real quick, since people didn't seem to know too much about our platforms, I want to talk a little bit about the services, and then talk about sort of how we've gotten where we are and where we're going next. So I asked who's using Event Hubs. A few less people that I know than I thought would say something. Does everyone know what Event Hubs is? Well, then I'm glad I kept this slide in here. Shubha's going to talk more about Event Hubs after me. I will just do a very quick introduction here. It really is a distributed data streaming service. So it is stream and telemetry ingress for low latency scenarios. That's what we designed that for. And it's really about having a partition consumer model. So unlike a queue where everything's going into a queue or like a database or like the message box, the partition consumer really spreads out the load so that it can be processed in parallel much more efficiently. And it's a time retention buffer. And it's really made to be an elastic component in the chain of stuff that you're stitching together in your solution. We've kind of positioned this incorrectly, I think, as an IoT type of service in the past. We are repositioning this as what it really is, which is a big data service. So where does telemetry and streaming fit in? This is what any a pipeline of application telemetry or any type of telemetry is going to look like. You're producing stuff on the one end, you're collecting it, you're ingressing it, you're doing some stream processing, which we usually see being fast and slow. We see people usually do both. Some will be sub-second, using things like Storm or Stream Analytics, and some will be batch-based, because the world still runs on batch. I've given up my holy war on that. And then you get to things like long-term storage and presentation and action type stuff that you're going to let users do things with your data. So where we live here in Event Hubs is in the middle of this. And you could think about this as something like IoT being on one edge and big data being on the other edge. So Event Hubs itself is not an IoT product, which too many people think that it is. It's really a big data product. As a conceptual architecture, this is what an Event Hub looks like. It's some FQDN that you're talking to, some URI in the web, and it's got partitions in it. The partitions each have data inside of them that's in order, and it's really a client-side cursor model. When you send data to it, all of your event producers are just sending into the Event Hub. So you're just flowing in, and if you don't do anything by default, we're going to round robin. This is why it's called a partition consumer model, because each of the partitions is separate, and when you go to read, you need to read from all of the partitions. So you're reading from one partition with one reader, from another partition with another reader. What's nice about this model is that it will scale pretty much indefinitely. So this is why we can do so much scale, because of we don't have time fighting for like a lock on a database. We don't use SQL in this. But you can read that stream of data over and over again. So you can add more consumer groups to it. You can read it multiple times. And it's a client-side cursor model. So when you connect, you say, hey, I want to read partition X from point Y, and you go forward. I have another analogy that I like for this, which I think people here will remember what these are. Yeah. Goes with the sideburns. This is kind of an easier analogy to understand. That Event Hubs is like a tape. So you're pressing record on this tape, and it's going forward and recording actually a couple channels at the same time. So this is kind of maybe an easier way to understand this. Which analogy do you like better, the first one or the second one? Everyone like the tape? Is tape cool? Okay. Some debate in there. What do people really do with Event Hubs? Again, this is where I'll end talking about Event Hubs, because that's the next talk. People do a lot of telemetry, application telemetry, internal to Microsoft and outside. Things like App Insights are built on Event Hubs. People do ad tech. Some of our biggest customers are actually ad tech companies. They do sensor telemetry a lot, and this is kind of where we bleed into some of the IoT type stuff. And there's a lot of user data and click streams going on. So this is where people are really innovating right now. And then amazingly, it's actually gaming. There's a whole lot of gaming companies using Event Hubs, and a lot of them are not from Microsoft. So yes, we have 343, which is Halo, and we have Xbox Live and other Microsoft subsidiaries using Event Hubs, but we have a lot that aren't. Not all of them want to talk about it, so I won't give out specific names, at least while I'm being recorded, but they're using it, and they're using a lot of it, and people do a lot of gaming, I'm surprised. One thing I do want to bring up is Event Hub's an IoT Hub. Who knows what IoT Hub is? Has anyone ever been confused about Event Hub's an IoT Hub? A few people, good. Not too many, that's good. This audience probably knows the differences. IoT Hub is really made for IoT stuff. When you're doing IoT, you should think IoT Hub. You really should, because you get things like bidirectional communication, you get things like per device identity, and you get things like device lifecycle management. Super important stuff that is not part of Event Hubs. When you're looking at doing something like telemetry or streaming, look more for something like Event Hubs. Here's where you're going to get a streaming buffer that can scale to millions of events per second. So we're going to be able to batch in real time on the same stream, and it's where we're going to be able to handle any type of volume that you're going to come up with. So I like these slides. One of the marketing teams came up with them. I think they're a good, easy way to say, hey, don't confuse these two things. They serve a different purpose. Just because you got a shiny new hammer, don't need to go see everything as nail. A little bit about Service Bus. This is, again, the subject that's near and dear to my heart. It's messaging as a service. It's queues and topics, so reliable asynchronous communication. A lot of features for things like temporal control, transactions, routing and filtering, and then sessions and convoys, which is actually something of the BizTalk customers in here who uses convoys in BizTalk. Anyone? Yeah, a few people, quite a few. I mean, I think I did convoys in almost every BizTalk solution that I worked on, which I don't know if that's a good thing or a bad thing. So, this trail of destruction behind me. Real quick, the basics of a queue. Do I really even need this slide? I mean, everyone here probably knows how a queue works if you're at a BizTalk conference or integration conference. So really, it's about just decoupling the sender from the receiver, getting transaction features, things like that out of this. Again, I was going to say, do I really need this? Just want to fast forward through that. And topics and subscriptions, another thing that, probably don't need here too much, so I'll fast forward through it. If you know how send ports work in BizTalk without using an orchestration, then you know how subscriptions work. Like, it's that simple. It's not a coincidence that the same teams built a lot of these things. So I'll skip past those. Enterprise messaging, it is a mature space. You're going to see companies like this in it, but it really is moving to the cloud now. We've had a tremendous amount of uptake in our premium messaging service bus platform, and we're really driving this move. So these are some of the features I wanted to talk about real quick. I won't really talk about them because I'm sure some of them will be shown in other demos and stuff. But this is why people use Service Bus, for things like scheduled delivery, for things like poison message handling, sessions, being able to age out messages when you don't get to them in time, and things like duplicate detection. Duplicate detection is actually like really kind of hard to do, and you get it for free really with our services. So this is a pretty good example of how easy something like setting a time to live on a message is in Service Bus. This is literally, if you just replace the connection string with a real connection string, this is literally what the code looks like. It's one little piece to say, hey, give me a TTL of 1 hour. So if you don't read this message in 1 hour, it'll go away. What's really cool about this, though, is that Logic Apps can support all of these features. So things like sessions to do convoys, things like transactions, things like TTL, message header information, all of this is built into Logic Apps now. So if you're not living in the world where you want to be writing C# or Java, you can actually use all these features from Service Bus in Logic Apps today. The team has done a really good job over the last year, really making Service Bus work really well with Logic Apps. So how do customers use it? I'm not going to play this video, but it's really cool. It just came out, what's the date today? 26th. It just came out 6 days ago, and this is from ASOS. And how they are using a bunch of the pieces in Azure, and they actually use Service Bus, and they talk a little bit about it in this video. So it's kind of cool to go see. That's a really typical example of what people are doing with Service Bus. It's one piece of a big application, but it's usually a very important piece. Here's my favorite one, relay and hybrid connections. I'll just talk about this real quick too. It's really about securely connecting on-premise data and services from anywhere. This underpins all of our hybrid stuff, in Azure. And it's giving you the ability to put a bunch of endpoints behind a single cloud endpoint so you can load balance on-prem stuff. And you can protect it. So Clemens, when he's here, or when he's talking to people, likes to point out that the acronym VPN has no S in it. There's no S for security in VPN. Like a VPN's just letting you plug someone into your network. That's quite insecure. Whereas something like Relay is actually letting you say, hey, just this endpoint, just this URI, not a socket, not a port, just this URI is exposed. And the nice thing about it, which scares the security people, is that it doesn't require any network changes. So where do you use this? This is actually surprisingly popular service, considering that we didn't invest in it for a long time. It's used by a lot of ISVs. You use it when VPN might be too costly or too difficult. So if you only have 1 or 2 or 10 sites to connect, a VPN's not a bad idea. But as you get more and more sites to connect, that becomes harder and harder to do. VPN equipment's expensive, the software is expensive, and it takes a skilled person to operate it all. This is one instance where you might have a lot of spokes in your hub and spoke sort of diagram. The other is where you need to keep data where it's supposed to be. People in the US especially tend to think this is more of an EU type thing, but we actually have a lot of regulations in the US about where data needs to reside. Service bus relay is actually pretty popular for that because you can keep your data where it is and use it from anywhere. So what are people really doing with this? So anything in Azure that's doing something on-prem is using Relay at some point in it. You could turn on a packet sniffer and look at it and see it there. We are decoupling location and security and network configuration in your application. That's really what we're doing. And this is what it looks like. You've got a client, you've got a service, and sane people put those behind firewalls, and you want to go access that service, it's not going to work, right? That's what the firewall does. And this is where Azure comes to help you out. Relay really flips this on its head. When the service starts up, it registers an endpoint. I went a little too fast. As an outbound connection. Firewalls usually let out, actually firewalls always let out outbound connections. It's proxies that might not let out outbound connections. So firewall lets the outbound socket out, it connects to Azure, opens up a channel, keeps it open, and when the client wants to talk to that service, it just talks to the endpoint in Azure. It doesn't call the service, and we make magic happen. So that is what happens there. It's a little bit more precise view of what's going on. Our clusters have a lot of servers in them, and when that service connects, it's going to connect to some node in our cluster. And when the client connects, it's going to connect to some other node. And that control channel, the service keeps open all the time. And when that client connects, it's going to send a message and say, hey, I want to start talking. And we route that through the server that it's talking to the server that the service is already connected to. And we tell that control channel, open up a new socket to this specific server so that you can talk to it. And this is how Relay really works. That's the magic of Relay. Very cool service, very useful. Good examples of where you use it. There are actually, this is a really cool one I've seen a few times now, which is doing RDP or SSH to on-premise stuff, which is kind of cool if you think about it. Like that's wild to be able to SSH into something like a room control device. That's pretty interesting. Securely, by the way. There's more than one company that does it. Some of them do really cool things like monitor and record all of the traffic that's going over the relay so that they can actually have value-added services on top of this. Really cool stuff. And another place that people might see it from is that BizTalk 360 uses Relay. So that's how you can, from the PaaS service, or SaaS service, see and control all of your on-premise stuff. So that's a pretty good example of why and where and when you would use Relay. So what have we been up to? We've been pretty busy, actually, the last year since I've been up here. We did create a new hybrid connection service to give a better home to the concept of hybrid connections. This service is not like our old Relay service. It is really WebSocket-based. Relay was WCF-based. The little diagram I showed, the dance, the rendezvous, that still happens the same way, but here you're really doing it through a WebSocket. So Clemens did a really cool demo at the MVP Summit, I think it was, where he showed using a browser as the client. And you don't need some Microsoft client, you don't need anything else. You just use JavaScript WebSocket, and you can talk to on-premise stuff, which is pretty cool. So we're pretty happy with that. We've rolled out native Java clients for all of our messaging products right now for Service Bus and Event Hubs. We're pretty big on Java, actually. We realize that who here has someone in their company using Java? Anyone? No one? Yeah, everyone does somewhere. It's especially the bigger the company, the more likely some part of it is using Java. We also G8'd our premium Service Bus service, and we now got it deployed to 19 regions, including here in the UK. And we rolled out a new portal experience. My team that's here is probably going to kill me because there's a bunch of other stuff that I couldn't think of to put on here because I'm just too tired. And now let's talk a little bit about what's coming up and what's ahead for us. So we have a lot of stuff we want to deliver soon. Some of these, I don't know, I guess we weren't going to disclose till they're done, but encryption at rest is coming next month for premium Service Bus and for Event Hubs. You won't have to do anything for that. It's going to be service-side encryption, so our storage will just be encrypted. Managed Secure Identity, or MSI. This is coming as well. Parts of Azure already have this, although I Googled it this morning and couldn't find anything. So I'm not sure how publicly we're talking about this, but what? No, it's not. This is actually, we use this internally for how our capture or archive feature in Event Hubs talks to your storage account. That way you don't have to paste a connection string. MSI is coming to every Azure service. We will have it by the end of this calendar year. And really what that means is you can give identity to things like your logic app or your VM scale set, and then you don't have to use a connection string to talk to Service Bus or SQL or other services. So this is pretty cool. Oops, if I just leaked that. Bring your own key. We're going to do bring your own key encryption at rest for our premium products. That's something we're looking at. We're interested to know how many people really want BYOK. So if that's something you want or you use or you need, please come and talk to me. And IP filtering. This is one that has been asked for quite a few times. Is anyone happy to see this? Yes. Yeah? Okay, yay. Good. We haven't written it yet, but we are writing it. The last thing we'll do is VNet integration. Again, this will probably just be for our premium services, things where we have resource isolation for you, but we will be addressing our lack of VNet support. And a completely new metrics pipeline is coming. We've already announced this. The new metrics pipeline is much faster. One embarrassing thing in our old portal and our old metrics pipeline is that we do 8 million requests per second, but you can't see your requests until like 20 minutes later, or you can't see your traffic until 20 minutes later. We fixed that. Azure All Up, we fixed that. Now Azure uses Event Hubs underneath, so the pipeline is very fast. So that's stuff that's coming. And then here's a really exciting one that I've been talking about for like a year. It just took us longer to do than I thought it would. And it's GODR, and this is coming for all of our messaging services this summer. GODR is a disaster recovery service or feature for our services, and this is what it looks like. It's giving you a dual region active-passive failover without client coordination, so you don't have to change your connection strings. So you're getting a single stable connection string or FQDN that you can use with our services. And what we're going to do is give you a REST endpoint where you can explicitly control failover so that you can trigger failover when you want to trigger failover between the regions that you've chosen. So it's user-controlled recovery time objective. Does that sound like something people want in the cloud? Yes? No? Really? No? Wow. God. Okay. Now the questions about this being available for IoT Hub, you will have to ask the IoT Hub team. Sorry. At first, no. IoT Hub's interesting because they have different requirements than us. So here's how it works. You're going to create an alias. It looks like a namespace, but it's not actually a namespace. It doesn't exist in any region. You're going to select your primary region and namespace name, and you're going to select your secondary region and namespace name. And what we will do is we will copy all of the metadata from the primary to the secondary all the time. So when you create queues or event hubs or policies, meaning connection strings basically, we will copy all of that stuff between the two. The secondary is really a slave at that point. You can't use it or change it because we will be writing it. And then you call a REST call to initiate the failover, and we'll kick out the old primary so it's no longer part of the sync. We break the sync, but your data is still there in the old namespace to go get because you probably want to go read your old messages, things like that. And for your senders and receivers, they won't know that anything's happened. There will be an IP break, like we will redirect the traffic, so they will reconnect, but all of our clients handle reconnection automatically already. So in pictures, this is what this looks like. You've got your alias, you've got your primary, you've got your traffic flowing in, it's going to the primary, and we're synchronizing that metadata to the secondary. When you trigger that failover command, we are going to reroute all of the traffic. We will eject the primary. It's still there for you to use. When you want to pair to another region, you select a new secondary. So you have to select an empty namespace for us to go. Like it can't be an existing namespace because we don't want to do merges. We want to overwrite what's there. You can go back to your same region, but you probably want to go to a new namespace. There are some caveats with this. This is a DR tool. This is not some sort of HA tool. Disaster means disaster. If this weren't being recorded, I would have a picture of Godzilla on here. because like it's not for, hey, things are slow somewhere, or it's Tuesday at 5 o'clock. It's for, hey, there's a fire or there's an earthquake in US West, which is a real possibility. And if that happens, that region might not be available for a while. So there is no state, meaning messages. We're not copying the messages when we do this. We have some requests for that, and it's something we're looking at for a different solution maybe. But right now we're not giving you an RPO, we're giving you an RTO. And you'll need to decide when to do the failover. Like, that's still your responsibility. Why don't we do it automatically? Well, because a solution that's actually using any of our messaging stuff never sits in isolation. You know why that 8.5 million requests a second is so high? Because we're not doing anything. Like, we're just passing data. You need compute, you need logic apps, you need other things to actually do stuff with your data, and you're gonna have to decide how to fail that stuff over. So we can't really do that. So you need to decide when the failover will be. And then you need to figure out what to do about messages in your old primary region. If they're not that valuable, you could just throw them away, and if they are, you'll want to go read them and reprocess them in some way. This is a fail-forward only model, as I mentioned. So I will take a couple questions, if there are any, before making one last statement. Questions? This is Seamus. He just turned 10. Right before I came out here. I stayed there for his birthday. Anything? No questions about messaging? Yes?
Do you have any ideas about providing claim check pattern?
The questions about claim check. The claim check. Yes, the claim check. That comes up all the time. You know what? So I should have mentioned this. Not only did we make new Java libraries, we made new .NET standard libraries, and they're all open source. So you can add the claim check pattern to it at any time. Yes. Now, one thing we did do with those libraries, though, is we've actually added, specifically for claim check and for encryption and compression, we've actually added a plugin to those libraries so that you can actually plug in with a class without having to recompile the library. So there is a plugin model for our .NET Standard and Java clients where you can actually start to do that stuff easily. I think it'd be a good feature. What we're really looking at doing is making a higher level library, kind of like Event Processor Host, where you can do more things like that. What we don't want to do is put in a dependency on storage on our clients for every customer, because that's really how we would do claim check. Great question. Anything else? All right. Then the one last thing I'll leave you with today is that messaging is really kind of an underappreciated space. Right? Has anyone ever had to run an Exchange server in this room? Or a mail server? Did an executive ever come up to you and tell you how great of a job you were doing running the mail server? Probably not. But the moment it doesn't work, people run after you. So messaging's a tough thing, and usually when people build a solution diagram, messaging actually ends up just being the arrows that connect all the pieces on the diagram. So they don't give it a lot of thought, but it does deserve a lot of thought. But one thing I can say is that my goal, our team's goal, is to make it so simple that messaging just happens. So transparent messaging. So imagine messaging like if there was no queue, like if it just happened transparently to you. And that is the thought I will leave you with for the until the next time when we can talk about some more interesting stuff. Thank you very much. This has been great to be back here in London.